you know how to substitute? Substitution helps lots of different things because of, obviously, you can substitute for anything. So substitution is really kind of huge, especially when you already have one of your variables solved by. So today, like I said, we're going to use substitution to solve our systems. It's like we talked about yesterday when we did graphing. We're looking for that kind of that point of intersection, but now we're not going to see the graph. We're going to find the values of x and y that show that. All right, so today we're going to use substitution to solve systems of equations. So here's our first system that we're going to have. Y is equal to 2x minus 1, and 3x plus 2y is equal to 26. Now think about graphing this. If we are going to use graphing to solve this. The first one's not so bad. And we have the y-intercept is -1. We have the slope is 2. So the first one's not bad to graph. But that 3x plus 2y equals 26, graphing that's going to be a whole lot of a pain in the butt. And so substitution is a method that we can use. Now the first thing you're going to look for anytime you try to use substitution is you want to make sure in step 1 that you have one of your equations solved for a variable already. So in this case, we have that y is equal to 2x minus 1. Y is solved for us already. So then what we're going to do is we're going to take a look at that second equation, this 3x plus 2y equals 26. And anywhere we see a y in that equation, we are going to substitute in what we know y is equal to. In this case, y is equal to 2x minus 1. So I'm going to take this equation right here, and I'm going to rewrite that equation as 3x plus 2. Now I know what my y value is. So inside of parentheses, I'm going to substitute that with what I know y is equal to, which is 2x plus 1. Or sorry, 2x minus 1. That then has to equal 26. Now you'll notice, now that I have my new equation, you'll notice that there's only an x in there. There's no more y's. So we've got it down to one variable. So now that we have it down to one variable, we're going to go ahead and solve this equation, in this case, for x. So our rules for solving say that we distribute first. So that gives me 3x plus 2 times 2x is 4x. 2 times -1 is -2. And that's equal to 26. Now we have 3 terms on the left side. We can't have any more than 2. So that means we need to combine like terms. So 4x and 3x, that makes 7x's. So I have 7x minus 2 equals 26. Now I have to get variables on one side, constants on the other. So we're going to add 2. 7x minus 2x plus 2x is just 7x. 26 plus 2 is 28. 7 times what is 28? Or 28 divided by 7 is 4. So now I know my x variable. My x has to equal 4. So now we've used substitution to find the x value. Now we're going to find substitution to use the y value, to find the y value. So we've got 2 equations up there. We have y equals 2x minus 1 and 3x plus 2y equals 26. You can substitute the x into either one of those equations. It doesn't matter which one you do. You're going to get the same answer. However, which one's easier to substitute it into, the yellow one or the orange one? The yellow one, right? Because it's already solved for y. So all we have to do is substitute it in there. So that's going to give me y is equal to 2. My x value I know now is 4. 2 times 4 is 8. 8 minus 1 is 7. So my y value is 7. My x value is 4. We are always going to write that as a point. That's my solution. So if I were to graph those two equations, that's where those two equations are going to intersect with each other. So the steps, again, make sure one of your equations is solved for y or x, doesn't matter. Once you've done that, substitute that value into the other equation. You can't substitute it into the equation you solved for. It doesn't work that way. It has to be into the other equation. In this case, we solved for x, and then substituted in for x, and solved for y. Okay? Let's look at a second example. So we've got y is equal to x minus 1, and x plus y equals 7. Okay, so I've got this first one, I've got the second one. The top one's already solved for y. So I'm going to substitute it for y in the other equation. So my other equation now is going to be x plus, well, my y value is x minus 1. And that has to equal 7. At this point, always just make sure you look to make sure you only have one variable. Just have x. Are the parentheses really needed in there? Not really. What's x plus x? 2x. So 2x minus 1 equals 7. Add 1. 2x equals 8. Divide both sides by 2. X is equal to 4. Now that we know the value of x, we need to substitute that back into either of the equations. I'm going to put it in the top one, because then I just have to go 4 minus 1. 4 minus 1 is 3. Always write your answer as a point in the coordinate plane, alphabetically x, y. So remember what that means. That means that the point 4, 3 is the point of intersection, and it also means that 4, 3 is a solution for both of those equations. Any questions so far? All right, let's look at another one. So now I've got 2x plus y equals 1. And 3x minus 5y equals negative 18. Well, our first step is to make sure that one of the equations is y equals or x equals. It doesn't matter which one you do. So either of these has done that. So what do I need to do first? Which equation are we going to look at? Top one or the bottom one? Which one's easier to solve for a variable? The top or the bottom? The top one. Why would I pick the top one? Because it just has a y right there, right? So what do I have to do to solve for y? Subtract off 2x, right? So if I have 2x plus y equals 1, if I subtract 2x's from both sides, then y is equal to negative 2x plus 1. Now I know what my y value is equal to. Now just a little hint at this point. Scratch that out. You don't want to use that anymore. Pretend it doesn't exist anymore. Because you can't substitute that back into the original equation. You have to substitute that into the other equation. So we're not even going to use that top one anymore. So we're going to substitute it into the 3x minus 5y equals negative 18. So that's going to become 3x minus 5. My y value now is negative 2x plus 1. And that has to equal negative 18. I'm looking through that equation now, and I'd notice that all I have is x's in there, so I'm good to go. So now what I want you to do is go ahead and solve that for x. After you solve that for x, go ahead and substitute that x value back into the purple one to find your x value, to find your y value. I'll give you about 2 minutes. Go. When you're done, you can go ahead and look up and check your work, see how you did. I got negative 1, 3. Any questions with this one? Any questions? Guys, you good over there? Y'all good? I know you are. All right, go ahead and work with your partner. Question number 4, just a hint, solve the top one for x. Solve the top one for x first, and then substitute x in there. Go ahead. Give you about 3 or 4 minutes to do that one. And I'll kind of go through it slow. Kind of let you get ahead of me a little bit, then I'll take my time a little bit to see how you do.
Yes.
Ooh, I don't know. Okay, when you're done, peek up, see how you did. A little bit of a harder one because you did get a fraction. Be careful, common error. Happens all the time. People would have put y equals 2. Because we have the numerator's smaller than the denominator, we have a fraction. Plug it in, you get 3 and 1/2. Just make sure we're paying attention over there. This is the only time some of you will see what's going on. Any questions with that one? I'm not going to have you do these. I'll just kind of watch what I do, but there are special cases. Okay, we have y equals 5x plus 3 and 5x minus y equals -7. I think we can all see what we would do. We've already solved for it. So we would have 5x minus 5x plus 3 equals -7, just substituting it in there. I've got 5x minus 5x. 5x minus 5x is just 0. And then I've got -3 equals -7. Is that a true or false statement? It's a false statement. If you get a false statement, there is no solution to that. False means no solution. And they're two parallel lines. Okay. With the other one, I would have 2x minus 2. I'm substituting the y. X plus 5 equals -10. So 2x distribute minus 2x minus 10 equals -10. 2x minus 2x is 0. You get -10 equals -10. Obviously, that's true. If you get a true statement, it's infinitely many solutions. So false means no solutions. True means infinitely many solutions. They're the same line. If you were to graph them, they'd lie right over the top of each other. So that is substitution. Substitution one's a good one to use, especially if you're already solved for one of the variables. If you're not solved for one of the variables like we did kind of with those last ones, there might be a better way to do that, and we'll talk about that method tomorrow when we talk about elimination. For today, you are going to Unit 1A worksheet. It is inside of Schoology. You can just go ahead and do the odds. The odds is enough. What I want you to, again, let's kind of preface this a little bit. Do the odds of the substitution ones, but where it's the spiral review, do all of it. So do the odds of the substitution part of the assignment, and then do all of the spiral review part of the assignment. You have 20 minutes, 30 minutes, lots of time. Get it done.